Okay, we are all convinced that the tropical diabatic heating associated with convection, especially the MJO and monsoon, are reaching into the high latitudes in both hemispheres, even into all the way into the Arctic and having impacts. What are the extratropical forcings of the tropics? When we looked at the table of the MJO phasing and NAO, we saw that there were negative, and I don't want to go all the way back, negative and positive phases of MJO of NAO based on the MJO phase, which means there is a transition happening. So this is an example of how NAO can then feed back onto the tropics. So Rossby wave diabatic heating sends MJO diabatic heating sends a Rossby wave into the Atlantic and can facilitate change in the NAO phase with a lag at intraseasonal timescales, and then the phase change of NAO can send a Rossby wave back. So this is looking at wave activity flux vector, which you can look up at 200 hectopascal from 26th to 29th April 2002. This period coincides with the initiation of an MJO event in the region marked by the rectangular box. So you have the MJO activity here and the extratropical activity there. So the initiation of MJO is facilitated by extratropical wave activity flux vectors. So you remember we talked about the primary MJOs and secondary MJOs. Primary MJOs are the ones that are born new from scratch, often found to be forced from extratropical forcing like this, and there are secondary MJOs, which is an MJO that is born, that goes around into the Atlantic, across the Pacific, and back over the African continent into Western Indian Ocean and gets re-energized. So the figure is not a very clean one, but you can find a better one in some of Tim Lee's later work showing that such an extratropical forcing of MJO initiation does work. So there is definitely extratropical forcing of the tropics, and the better one is seen here, where we are looking at the Meteosat infrared image of tropical plume over northwest Africa. You can barely see it here. At 00 UTC 31 March 2002, superimposed are streamlines and isotachs on the 345 Kelvin isentropic level. If you remember how the isentrops slopes, you know where that is. So they are showing isotachs of 40, 50, 60, 70 meter per second from ECMWF Toga analysis. The 345K level is close to 200 hectopascal in the tropics. Streamlines that indicate extratropical wave incursion into the tropics. So there are these specific places called the westerly ducts or the upper tropospheric troughs where the extratropical breaking Rossby waves and the associated potential vorticity can inundate the tropics and can affect the MJO convection and also West African easterly waves and other tropical activities. I have to be sure that they affect the easterly waves, but you can look it up. But they are called potential vorticity streamers. So they happen in the northwest, northeast Atlantic and Northwest Atlantic and Northeast Pacific. I have some lectures on extratropical forcing of the tropics in the tropical dynamics course that you can look up. There are also summertime forcing from the extratropics of the boreal summer season in terms of interseasonal variability in the Indian monsoon, for example. This is a paper by Saurav Chatterjee et al. I have these podcasts in more details in the lectures on monsoon extremes that I'm posting already on YouTube as well. So this argues that the sea ice extent decline in the Kara Sea in the northeastern North Atlantic has an impact on jet stream characteristics and also sets up a anomalous meridional circulation by impacting the blocking pattern in northwest Europe, and that steers the Rossby wave activity flux southward and eastward from the Atlantic Mediterranean region into the northern Indian Ocean, and sets up a stronger subtropical high and upper level divergence which drives a low level cyclonic circulation. And if cyclonic circulation is set up and it demands moisture, then the moisture has to come from somewhere. So this paper argues that positive sea surface temperature anomalies in the Arabian Sea since the 1980s are able to supply the moisture for this surface cyclonic circulation set up by these chain of events, leading to enhanced moisture convergence and extreme rainfall late in the season. So the Kara Sea sea ice anomaly is seen in June, July, August, and the extreme rainfall events happen in August into September. 2021, for example, is seeing a strong extreme activity over India. The season till August had been lackluster with severe droughts in some regions. This is just looking at the geopotential height anomalies of 200 hectopascal I think in the high latitudes and low latitudes, and arguing that there is a high correlation between them, showing the link of the upper atmosphere signal coming down from the extratropics into the tropics and affecting the monsoon. The other paper, sorry I forgot to put the link here, is from Bora, Venugopal and others, which appeared in Science just a few weeks ago in August 2021, I think, or July 2021, and they are looking at Indian monsoon droughts during El Nino and non-El Nino years, and their argument is that the El Nino year evolves, El Nino drought evolves this way. This is going from June 1st to the end of September, and the deficit starts in the beginning of the season itself, grows, and then reduces a little bit but comes back again. So the accumulated or cumulative rainfall for an El Nino drought is essentially deepening throughout the season to produce larger deficits than a non-El Nino drought. But the key thing about the non-El Nino drought in this paper is that it starts with a deficit that may be even steeper than the El Nino drought. There are only 10 events in a century of non-ENSO droughts, and I think there are about 13 ENSO droughts, so the sampling issue is always there with these kind of investigations. But the non-El Nino drought typically becomes active again in the middle of July, August, and this is very dissimilar to the El Nino drought. And the late season collapse here in the non-ENSO drought is argued to be caused by, you can see that in the cumulative rainfall as well. The deficits in the late part of the season are similar between non-ENSO and ENSO droughts, but the non-ENSO droughts are much milder in terms of rainfall deficit compared to ENSO droughts. So this deficit in the late season here is attributed to a Rossby wave coming down from the North Atlantic with a cold SST anomaly in the mid-latitudes, which has cyclonic circulation associated with it, and a Rossby wave train is identified to drive this kind of a break. So these kind of connections to the monsoon from high latitudes were observed back in the 1960s, and also the extratropical forcing of the tropics in the Pacific and Asian subcontinent were also observed in the 1960s and 70s, but now they are being recast in terms of the details and potentially the relation to Arctic ice melt or other trend signals in the Arctic Circle or in the North Atlantic. As you know, the warming patterns, the AMO and so on, have specific features in the North Atlantic, but it's fairly clear that mid-latitude sends potential vorticity streamers in certain windows in the Northeast Pacific and Northwest Atlantic, and there are also Rossby waves coming down that can affect the MJO convection, and boreal summer season there are Rossby waves coming down and affecting monsoon break periods and even non-El Nino droughts. Only 50% of the Indian summer monsoon droughts are explained by El Nino, so it's good to have an explanation for the non-El Nino droughts, as they are playing a big role in the monsoon variability, and droughts are always quite impactful on GDP, grain production and so on. So if there is a mechanism, especially if there is predictability to the signal, then obviously that's good to know. Okay, so that's the quick examples of extratropical forcing of the tropics. Now we will go on and look at the feedbacks between the tropics and the extratropics. So we looked at tropical forcing of the extratropics, extratropical forcing of the tropics, and now we will see how they may be feeding back to each other in certain features at interseasonal timescales. Okay.